23, got these notes yesterday. I had this video all ready for you, and then I went to the computer to upload it, and it was just not working. So that's why you didn't have a video. I tried to make it, and for some reason it didn't work good like I did on Monday. We start out pretty easy. Stuff that you can do. This is graphing inequalities, but as we kind of do it in Algebra 2 style, it gets a little more difficult than maybe what you saw in Algebra 1. Graph x is less than 2. That means I'm going to put a dot at 2. What kind of dot am I going to put? Open dot. Unless it has the equals, I'm going to put an open dot. This means x is all the possible numbers that are less than 2. Would those be left or right of that dot? Left. You can also think of this as an arrow telling you where to go. Go left. It points left, so put your dot, and then draw your arrow going left. Graph x is greater than or equal to -1. So I'm going to put a dot at -1, but what kind of dot am I going to put this time? Closed dot. Why?
Because it's equal.
Because it's equal to. When it has the equal to, it's a solid dot at -1 right here. If I am greater than or equal to, which way will I go? Going to the right. It's like an arrow pointing right, telling you, please shade right. It's saying, really, x is all numbers greater than or equal to -1. And those numbers would be the numbers to the right of -1. Now, just so that you remember, because sometimes you might have like a brain fart and forget which ones are which, note the type of dot used for each sign. When do we use open dots? Less than?
Or not equal to, less than or greater.
Yeah, less than or greater than, without the equal to with them. Then when do we use closed dots? Less than or equal to, greater than or equal to. Also note which way do we shade or which way do we go do our arrow. We shade left when what?
It's pointing left.
When it's pointing left, which are our less than signs or our less than and equal to signs. Points left, we shade left. Likewise, points right, we shade right. So now if you forget and your brain's not working really well one day, you have these notes, come back to them and look and remind yourself of the dots and the shades on number lines. And let's go to example 2, example 1, or example 3. Example 1 and 2 are cheesy. This is a real problem. All right, here's an inequality. And it's got 4x plus 3 less than or equal to 2x minus 3. First thing you need to do is written right underneath it. What? Distribute the 2. 2 times x and 2 times -3. So you've got 4x plus 3 is now less than or equal to what?
2x minus 6.
X minus 6. First thing you got to do is distribute. The next thing you need to do is get your x's together. So you have 4x over here and 2x over here, and really, ultimately, you always want your x's to end up on the left side. So let's go ahead and move this to x. Tell me how to do it.
Minus 2x plus x.
Put a little minus 2x underneath it. Like that. Cross it out. Now 4x minus 2x is what?
2x.
2x plus 3 is less than or equal to -6. It's going to be -9. How did you get that?
Minus 3.
Minus 3. And minus 3. Let's move the 3 over now. At this point, you should be seeing here's your x piece. Here's a number that needs to go away. So we minus it away. Get it over there to the right side. 2x is now less than or equal to -9. And you are so close to being done. You've got 2x on the left. This is called the coefficient. I need you to get the coefficient off. Please don't say subtract. What do you do to get the coefficient off of my letter?
Divide.
Divide. Is this 2 negative? It's just regular 2. So what does that mean about your sign? Leave it alone. It's the same. It's good as it is. Divide by 2. No reason to change. Now, isn't the right side negative?
Yeah.
That doesn't mean anything as far as flipping the sign. It is going to be negative 4.5 over there. X is less than or equal to negative 4.5. That means I need a dot at negative 4.5. That is located halfway between negative 4 and negative 5. But what kind of dot am I looking for? Solid dot at negative 4.5. And I'm going left or right? Look at A. Do I have a solid dot at negative 4.5? Going left?
Yes.
Sounds so depressed.
Well,
Yeah.
what do you expect at school?
I expect you to be cheery and happy all the time.
You just came out of chemistry.
But it has
Oh,
kids
chemistry is the
on
worst.
Oh, I'll have to go talk to her.
Football's the
Like, don't
worst.
send me a bunch of
Don't
depressed
tell her
students.
that we
No
don't
more-
need to do math in
No
her
more
class.
significant figures.
Oh.
Football's
You better learn your significant figures. What's wrong with answer B real quick? Just last thing. What's wrong with B? B looks so much closer. It's open. And it's not supposed to be open because you know from the
Shelby's
beginning.
open-minded.
You really know from the beginning that you're not going to have an open dot. Okay, example 4. I need everybody to follow through with example 4 because it's ugly. Alright, when you see this problem, if you raised your hand and asked for help, what do you think the first thing I would tell you as I walk by would be?
Look your nose.
Write it down.
Well, if I was actually going to give you a 1 or 2 words of advice, kill the fractions, which is what we are going to do on this one. So I've got it written down below, and I want to make sure that everybody has this skill. Fractions are ugly. Fractions will like bend your mind in different directions that you don't want it to go. We can make it an easier problem if you understand this killing fractions method. So here's the problem. It's written like this. Kill fractions. My goal in kill fractions is to do what?
Get the numbers all the same.
Get
Denominators.
the bottoms to all be the same. Unfortunately, I've got a 7 and a 2 and another 7. I can't make this 2 turn into a 7. So what do I need to turn them both into?
14.
14. If I just said, what is 7 and 2? It's 14. I can make a 7 turn into a 14, and I can make a 2 turn into a 14. So the 14 is the magic number. Now on this first piece, what do you got to multiply 7 by
2.
to make it 14?
2.
2. But you got to put a
2x.
2 over 2. If you remember the golden rule of algebra, it's like do unto the left side as you do unto the other. We are not breaking that rule here. All you're doing is putting 2 over 2, which is a fancy way to write a 1. And you are allowed to multiply anything you ever wanted to by 1 and never changed anything. So you can put a 2 over 2 right here, and that's fine. Right here, you're going to put a what over what? 7 over 7.
2 over 2.
And then a 2 over 2 right here. Now on that right side, that is the place where we might make mistakes. So we'll point that out. This first piece turns into 2x over 14. That's easy. 2x over 14 minus, now it's minus what? 7x over 14. On this third piece, on the right side, when you have 2 and you got 2 pieces up here, it's not just 2x minus 7.
2x minus 14.
You got 2 things up there, you have to distribute. Both of them get multiplied by 2. It's 2x minus 14 over 14. At this point, I would say, is everything in this inequality a fraction?
Yes.
Does everything have the same bottom?
Yes.
So then cross them out. You successfully got all the bottoms to be 14 so that you could cross them out. And now rewrite the problem without fractions. 2x minus 7x is 2x minus 14. I want to discuss a little trick with you right now. When you are looking at an equation or an inequality, and you see that there is the exact same piece on both sides. You see this 2x. A positive 2x. You see that 2x. A positive 2x. Then we can basically cross those pieces out. You could combine like terms if you wanted to. But I would, before even thinking about combining like terms, eliminate these terms. And when I say they're the exact same, if this was 2x and that was negative 2x, that's a no-go. That is not the exact same. But if it's positive 2x, we can cross them out. If you think about it, if I'm minus 2x on both sides, they would kill each other off. That is why these pieces simply can just be crossed off right off the bat. And really I have negative 7x is less than negative 14. The reason that's helpful is I get to skip steps that way. I don't have to combine like terms. I don't have to bring this x over. I just crossed it out and I'm already to the coefficient part. Is my coefficient negative?
Yes.
Yeah.
I'm going to divide it off, but what does that mean if my coefficient's negative?
Sign can swap.
Sign will come this way. Sign will flip. This is negative 14, or I mean this is negative 7. So you will flip the sign. And now x is greater than what? 2. I want a dot at 2, but what dot do I want?
Open.
Open, and then which way will I go?
Right.
So I want an open dot at 2, and I want to go to the right. I got an open dot at 2, but I'm going the wrong way. I got an open dot at negative 2, an open dot at negative 2. Here's an open dot at 2, going to the right. All right, compound inequalities. This is a real hang up, and this will pop up on objective 23, but it will also pop up on future objectives. There are objectives that are just about compound inequalities, so this will get its own objective that we will cover tomorrow. When it comes to compound inequalities, one way you might see a compound inequality is you might see two different inequalities with the word "and" in between them. And means something special. And really means if we put both of these inequalities on the same number line, where would they overlap? So and means overlap. Write that. And means overlap. Where would they overlap? So I will do them both. The good thing about this is that these are actually really easy. I'll work out the first one. When we do that next example, we'll just write it down. On the first one, all right, x plus 4 is less than or equal to 7. And the second one is negative 2x is less than 4. With an and in the middle. All right. On this one, what do I got to do?
Minus 4 on both sides.
Minus 4 on both sides. And I'm done. X is less than or equal to 3, and done. On this one, I need to divide both sides by what?
Negative 2.
What does that do with my sign? Flips it. If you divide both sides by negative 2 and flip your sign, you get x is greater than negative 2. Draw yourself a little number line. This does not have to be a perfect work of art. I just need a little number line in here so I can figure out my overlap. 0. I need a dot at 3. So I'm just going to go 1, 2, 3 right here. 1, 2, 3. What kind of dot am I going to put here? Close dot. And I'm going to go which direction? Left. That's this. Now time for this. I'm going to go put a dot at negative 2. What kind of dot?
Open.
Open dot. And which way will I go?
Right.
I'll go to the right. There's negative 2. And I'm going to put an open dot at negative 2. Better color. Let's put this one. Open dot. And I'm going to the right. The question is, where did these things overlap?
Never mind.
Where'd they overlap?
Forget about it.
Yeah, between those two dots, they overlap right here. The overlap is the answer. So we should have an open dot at negative 2, and we should have it shaded all the way to a closed dot at 3. So you have these two dots connected. If you think about it, if you had our first arrow was going this way, and our second arrow was going this way, the overlap is between the two dots. So which answer shows that?
B.
B. Open dot at negative 2, it was overlapping until you got to that closed dot at 3. Now this is for and. When you do compound inequalities tomorrow, we might see some that are or problems, and that is a little different. All right, On these two ands, I'm not going to write how to do these two inequalities. I just want to know what the answers are. If you had x plus 2 is less than or equal to 3, what's that going to turn into?
X plus 1.
Less than or equal to 1. And you'll divide both sides by -9 and flip your sign, and x will now be greater than what?
Negative 4.
-4. X is greater than -4. I need a number line sketch.
C.
I put a solid dot at 1 and go which way?
Right.
Which way? Which way?
Left.
Left. That's at 1 and I'm going left. I put a dot at -4. Open. And I go which way? To the right. And I seem to be overlapping between those two dots. So once again, put those two dots and give me the overlap between them, as in which answer? C. Now, keep in mind, both examples you saw on here. Eyes this way, eyes this way. Just, both examples you saw here, you had one arrow go this way and one arrow go this way. And the overlap is between the two dots. It does not have to be the case that they're always going to go opposite directions. If you had one arrow going this way and then another going the same way, the overlap could say if we had our -4 and you had your 1 and we were going the same way. We're both greater than. So here's greater than. And then you have -4 and you're still greater than. Where does the overlap start happening here?
-4. Oh.
Is it overlapping here?
1.
Yeah, this is 0 right here. It starts overlapping at 1, and it looks like it's overlapping just forever going that way. So if they're both going the same way, think this one's going here, not overlapping, not overlapping, not overlapping. Now it overlaps from that 1 to infinity, just forever. So if they're going the same way, figure out where they're overlapping. This could work either way. If they're both pointing left, it would look like that. If they're both pointing right. So, and means what? And means overlap. Sketch them. Just give me a little sketch, and then you'll figure out where the overlap is. And that is it. We'll see more compound inequalities.
Have a test.
Objective